Hello, ladies and gentlemen. Welcome back. We are looking at Chapter 7.1, Graph Exponential Growth Functions. So, what are we looking at here? So, an exponential growth function. A real simple equation, y equals a times b to the x power. Now, b is greater than 1. Ladies and gentlemen, when that b is greater than 1 and the a is greater than 0, the function is an exponential growth function. Okay, that means it's curving up from left to right. Okay, we've got a new word here. Okay, you may need to use the pause button so you can get it copied down. Okay, we've got what is called an asymptote. A line that a graph approaches more and more closely, but it does not cross it. Okay, so you can see that this line right here is getting closer and closer to that x-axis, but it's not going to cross it. Okay, we're going to go into quite a bit more detail with that. Let's start looking at some examples. So our first example here is y equals 3 to the x power. Okay, I'm just going to go ahead and put that into my y equals 3 to the x power. Okay, I'm going to go ahead and look at the graph, and we can see that it is curving up. Okay, it comes from the left and it curves up like that. Now I'm going to be a little bit more precise with some of my dots. So I'm going to go ahead and go to the table, and I need to fix my table here really quick. Let me go ahead and fix this. Okay, don't worry about what I'm doing there. All right, here we are. So I'm going to go ahead, and you will notice if I scroll to the negatives, the y values keep getting smaller and smaller and smaller and smaller. Okay, so I'm going to go ahead and I'm going to put a couple of dots on my graph. 0, 1, 1, 3, 2, 9. Okay, so I'm going to go ahead. So what did I say? Again, back to our table. 0, 1, 1, 3, 2, 9. Okay, now I can go ahead and plot those pretty easily. Over 0 up 1, over 1 up 3, and over 2 up 9. And again, in our table, you will notice, ladies and gentlemen, that when I go into the negatives, the y value, the y column keeps getting smaller and smaller and smaller. Okay, and then eventually it turns it to scientific notation. See, that's scientific notation. So it's not a negative. Okay, so that line kind of goes like this and then curves up like that. Okay, and an arrow on each end. Now, ladies and gentlemen, it's not going to cross this x-axis. Okay, that is our asymptote, ladies and gentlemen. Those numbers are getting closer and closer to 0. So our asymptote is y equals 0. Okay? Now, the domain, those are the x values. Well, if I look at my calculator, and we did this in a different lesson, ladies and gentlemen, if I look at my calculator, okay, you see those negatives all have partners, and all of these positive have partners. So the domain here, ladies and gentlemen, is all real numbers. And I'm just going to use my little symbol that I use for all real numbers. But the range, okay, the range values, ladies and gentlemen, again, we have an asymptote. That's a horizontal asymptote. That's that line that it cannot cross, right? And it's at y equals 0. Now, when I look at the calculator and I look at my y values, I notice that, again, 0.333 and then 0.111, I'm getting smaller and smaller, looking at the y column, and smaller. Okay, it's approaching that asymptote, ladies and gentlemen, meaning it's approaching 0, but it's not going to cross 0. So that means the range, ladies and gentlemen, here is going to be y is greater than 0. Okay, the asymptote is 0, that's the line it will not cross. The range is going to be greater than 0. It's going to get really close to 0, but it's not going to get to exactly 0. All right, let's keep going. Let's look at the next one. Okay, 1/2 times 3 to the x power. So I'm going to go ahead and go to my calculator, and I am going to go ahead and I'm just going to start over, folks. I'm going to go ahead and put 1/2 times 3 to the x power. All right, I'm going to go ahead and look at the graph. Okay, there it goes. All right, so now I'm going to go ahead and look at my table. And let's see what I have going on in my table. Well, I don't have quite as nice of dots that I can plot. I got 0.5, 1, 1.5, 2, 4.5. Okay, so I'm going to go ahead and put those in my table anyway, because really those are the only ones I have to graph. So 0.5, 1, 1.5, and 2, 4.5. Okay, I'm going to go ahead and graph those quick. So let's see, 0 up 1/2, over 1 up 1.5, over 2 up 4.5, 1, 2, 3, 4.5. All right, so and then it looks like this again. Okay, well, ladies and gentlemen, what that half did was it's compressing it down. Okay, we've done this before. How does that 1/2 affect the graph? Well, this is a vertical compression. Okay, it's a vertical compression. Now, did the asymptote change? No, the asymptote is still right here, right on that x-axis. The asymptote is y equals 0. Okay, the domain did not change. The domain is still all real numbers because all of the x values work. Okay, the range, however, is affected by the asymptote. The range, ladies and gentlemen, is y is greater than 0. Again, it's approaching 0, but it's never going to get exactly to 0. And so therefore, and you notice that it's going up, y is greater than 0 for the range. All right, let's look at another one. Okay, this one we have a +2 on it. All right, so I'm going to go ahead and go to my calculator, and I'm going to go ahead and clear that out, and I'm going to put 3 to the x power +2. All right, I'm going to go ahead and look at the graph. Ah, cool. Okay, it looks like it moved up, doesn't it? Okay, it looks like it shifted up, translated up. Okay, let's look at the table. All right, so let's see what's going on here. All right. Look at the y values. 2.0001. Look, now it's just staying at 2. Oh, that's pretty cool. Okay, let's go back down. Now, technically, it's not reaching 2, but we'll talk about that in a second. All right, so what can I graph? Well, I could graph the 0, 3 and the 1, 5. Okay, those would fit. All right, so 0, 3, 1, 5. All right, so 0, 3. Let me make that blue. I want to stick with my colors here. And 1, 5. And when I look at that graph, ladies and gentlemen, it looks like right here, and when I looked at the table, remember how it was not changing when I got to a certain spot? Okay, the y values. Okay, look right there. So it looks like, ladies and gentlemen, that the asymptote is right here, ladies and gentlemen, at y equals 2. Okay, so when I graph this, I do not cross that line, and I do that little bit right there. All right, so the domain has not changed. Okay, the domain is still all real numbers. The range, however, ladies and gentlemen, since this plus 2, okay, it shifted it up 2, okay? So we're going to say translate up 2 units. That means the asymptote moved up 2 units. And when we write the range now, ladies and gentlemen, we're going to say that the y, since it's curving up, is greater than 2. All right, let's keep going. Okay, this one has a x plus 2 on it in the exponent. I wonder what that's going to do. Okay, so let's see. We're going to go here, clear that out, and I'm going to go 3 raised to the x plus 2 power. All right, I'm going to look at the graph. Oh, it looks like it moved over left, doesn't it? Okay, it looks like it moved to the left. Let's go ahead and look at the table. Okay, well, let me get down so I can find some numbers to graph. Okay, so it looks like -2, 1, -1, 3, 0, 9. Okay, so -2, 1, -1, 3, 0, 9. Okay, let me graph those. So -2, 1, that would be right here. -1, 3, that would be right there. 0, 9, that would be right there. And let's see, let's take a look at the graph again real quick. And it looks like, okay, it looks like the asymptote is back at 0, doesn't it? Because it's approaching that x-axis, but it's not crossing it. So my asymptote is going to be right here. So when I draw my curved line, ladies and gentlemen, I'm going to go like this. There we go. All right, so what did this one do? Well, this one translated left 2 units. Okay, this makes it translate left 2 units. Where on the other one, it translated up 2 units. Look at the difference. What's different between the equation? All right, so my asymptote is back to 0. My domain has not changed, ladies and gentlemen. My domain is still all real numbers. But the range, again, is affected with the asymptote. The range is y is greater than 0. All right, let's keep going here. Next one. Okay, so this one's got x minus 4 plus 5. All right, well, it's got 2 things going on here. Oh my, okay, so let's take a look. So let me see. Let me go back again. -4 and then the +5 in the back. So I'm just going to go up here and I'm going to go ahead and change this to an x minus 4. And then I'm going to go ahead and put a +5 here. Okay, I'm going to look at the graph. It's up. Whoa, and it's way over to the right. Okay, well, let's see. What kind of points can I draw or plot? Let's see here. Are there any good points that I can put? Well, it looks like 4, 6, 5, 8 are the only ones that are going to fit. 4, 6, 5, 8. Okay, over 4, 1, 2, 3, 4, up 6, 1, 2, 3, 4, 5, 6. Okay, so there's one dot. And then 5, 8, that's going to be right there. Well, ladies and gentlemen, if I look at the graph, I notice that it shifted up, right? It shifted up. Look, 1, 2, 3, 4, 5, count my tick marks. Well, the +5 in the back tells me that the asymptote, ladies and gentlemen, is at 5. Okay, so my asymptote 1, 2, 3, 4, 5 is going to be right here. So that's the line it is not going to cross. Okay, so now I can go ahead and I can go ahead and draw my line in there. There it is. So this one did 2 things, and I'm going to type this instead of write it. Okay, this one did two things. This one translated up 5 units, and that affected the asymptote, and right 4 units. Interesting. Notice how inside, or it's a -4, but it translated right. This one was a +2 and it translated left. Ooh. Okay, watch out for that. All right, well, the domain did not change. It is still all real numbers. Okay, but the domain did change. The domain is affected by the asymptote. So the domain, or the range, sorry, the range is y is greater than 5. And again, if I go to my graphing calculator, I will notice when I go to my table, if I scroll up, eventually you'll notice in the y column, all of a sudden it's just 5s. Okay, that doesn't mean it is 5. It's approaching 5. It never technically gets there because the calculator is rounding it. Okay, it's like 5.00000000000000001. Okay, well, the calculator is going to go, I'm just going to make that a 5. All right, so that doesn't mean it is exactly 5. It's very, very close to 5. All right, let's see what else we got. We got a little bit more here. Oh, yes, exponential growth models. Yes, we got to get into some word problems, ladies and gentlemen. So we've got an equation here, y equals a times 1 plus r to the t power. All right, let's see what it says. In 1970, the population of Kern County, California, where Bakersfield is located, was about 330,000. From 1970 to 2000, the county population grew at an average rate of about 2.4%. All right, well, A, ladies and gentlemen, that is our starting amount. Okay, let me draw some arrows here. So our starting amount, obviously, is the 330,000. That is our starting amount. Okay, the rate, oh, I noticed here it says as a decimal, folks. Well, we have to convert this to a decimal. And remember to change, when changing a percent to a decimal, divide by 100. So the rate here is 0.024. Okay, that's our rate. And then t is our time. Okay, well, the first thing we're going to do here is write an exponential growth model giving the population P of Kern County T years after 1970. All right, so here we go, ladies and gentlemen. We're going to go y equals, okay, I'm looking at this formula right here, 330,000 times 1, it's a growth model, so 1 plus means it's growing, the 0.024, the rate as a decimal, to the t power, okay? Because it doesn't tell us what t is, so we're just going to put the t back in. Okay, now let's go ahead and look at what else it says. About how many people lived in Kern County in 1990? Well, let's see. So we've got 1970. And we want to know in 1990. All right, so it says after 1970. So that would be 71, 72, 73, 74, 75, 76, 77, 78, 79, 80. Okay, that's 10 years. And if you count it, that's 20 years, isn't it? Okay, that's 20 years later. We're not counting 1970. Okay, we're starting with 71, 72. All right, so that means t is going to be 20. So y equals 330,000 times 1 plus 0.024 to the 20th power. All right, well, calculator time on that. We'll just do that on our home screen. 330,000 times 1 plus 0.024. Now, ladies and gentlemen, you don't need the 0 in front of the decimal if you don't want, and you could actually leave this plus sign off. You could go 1.024. All right, I'm going to close it to the 20th power. So the population is 530,200, I'm going to round it, 90. Okay, 530,290, because we can't have part of a person. So approximately 530,290. Okay, pretty straightforward on that. Rewatch it if you need to. All right, let's see what else we've got. I think we got one more. Yes, compound interest. We're going to be getting into compound interest quite a bit. All right, let's see. So A equals P times 1 plus R divided by N to the NT power. Okay, here are all of our notations. A is the number of years, amount after T years. P is the principal. R is the rate as a decimal. T is time in years. N is the number of compounded per year. Okay, so let's see here. I'm going to write this formula a little bit further down so that I don't have to scroll up to look at it. Okay, so you deposit $5,500 into an account that pays 3.6% annual interest. All right, after 2 years. So first of all, let's change this to a decimal, 0.036. Okay, divide by 100 if you can't do that in your head. The balance after 2 years. Okay, semi-annually. Semi-annually, that means twice a year. Okay, well, here we go, ladies and gentlemen. I'm going to start plugging the numbers in. So the amount of money is going to equal the 5,500, that's the P, that's the principal, times 1 plus, okay, the rate, ladies and gentlemen, 0.036. Okay, again, you don't need the 0 in front of the decimal. Now, the N is the number of times compounded per year. Semi-annually means twice a year. So that means I need to put a 2 underneath that, close it, and then in the exponent, ladies and gentlemen, notice right here it says N times T. Well, N is 2 times, and then T is the number of years, 2 years. All right, now that's a 4. Okay, if you'd rather just put a 4 there, ladies and gentlemen, you are certainly welcome to do that. So let's take a look. You've got $5,500 times 1 plus, okay, 0.036 divided by 2, close it, because semi-annually is twice a year, so you're splitting that interest rate into 2 times a year. Okay, to the power of, now you can go ahead and put 2 times 2 there, ladies and gentlemen, if you want, or, okay, I never liked doing that. I'm just going to go ahead and do 2 times 2 in my head, and I'm going to put a 4 there, okay? And I'm going to hit enter. Now, this is money. Cool. So after 2 years, you now have $5,906.82. Remember to round 2 digits past the decimal. So you now have $5,906.82. All right, next one. Monthly. Okay, well, monthly, ladies and gentlemen, that means every month. Okay, and there are 12 months in a year. So that means you're going to get, it's going to compound it every month. So here we go. So the amount of money equals $5,500 times 1 plus the 0.036, but this time we're going to divide by 12, close it, to the 12 times 2, okay, because 2 years, 12 months in a year, 12 times 2, that's going to be 24. All right, so let me go ahead and do this on the calculator. We've got the 5,500 times the 1 plus the 0.036 divided by, this time 12, close it. Now again, instead of going 12 times 2, ladies and gentlemen, okay, I'm just going to put 24 there. There's 24 months in 2 years. All right, so 24, and now I have $5,909.97. All right, so now we have $5,909.97. Notice, ladies and gentlemen, we earned a little bit more money because it compounded it 12 times a year instead of just 2 times a year. All right, ladies and gentlemen, let's see. That was it. All right, good luck, ladies and gentlemen. Rewind and rewatch if you need to. We'll see you soon. Bye.